Bangladesh, Nepal, and Sri Lanka. He completed his bachelor's in mechanical engineering from Mahatma Gandhi University and master's in transportation and mobility management from RWTH Icahn University. He has worked as project assistant, student research assistant at RWTH Icahn Germany, where he is currently working as a scientific researcher. Bangladesh, Nepal, and Sri Lanka. Without any further ado, let us welcome the chief engineer to take on the lecture and master's in transportation and mobility management from RWTH
So,
Icahn
Sanskriti, it
University.
was
He has
quite
worked as
not so
project
audible.
assistant,
I think you were far
student
away
research
from your
assistant at
microphone.
RWTH Icahn Germany, where he
Um,
is currently working as a
Hello,
scientific researcher.
Sanskriti,
Yes,
and
sir.
there's a lot
Without
of
any
background
further
noise
ado, let us
behind
welcome
you.
the chief engineer to take on the lecture and master's in transportation and mobility management from
So,
RWTH Icahn
Sanskriti, it
University.
was
He has
quite
worked as
not so
project
audible. I
assistant,
think you were far
student
away
research
from your
assistant at
Is my
microphone.
voice
RWTH Icahn
audible
Germany.
now?
He is currently working as a
Hello,
scientific
Sanskriti,
researcher. Yes,
and
sir.
there's a lot of
Without
background
further
noise
ado, let us
behind you.
welcome the chief engineer to take on the lecture and master's in transportation and mobility
Rajiv, it's
management
fine for
from
me. I could hear.
So, Sanskriti, it was quite so. Maybe if you don't mind, Sanskriti, we were far away from the
Is my
system.
voice audible
It
now?
would be good to know who's Sanskriti,
Yes,
and
sir.
there's a lot of background
Without
noise
further ado,
behind
let
you.
us welcome the
Very
chief engineer to
well
take on the
audible,
lecture
so that in future in our archives
Rajiv,
we
it's
would
fine
not
for
be
me. I
researching
could
it.
hear.
That's so, Sanskriti, it was quite so. Maybe if you don't mind, can you come closer to the mic
Is my
and
voice
be
audible
quite
now?
well audible
to know who is
and
Sanskriti.
again
There's
repeat
a
the
lot
same?
of background noise behind
Is
you.
my voice
Very
audible now?
well audible.
No, not at
So
all
that in
audible.
future in our archives we would not
Rajiv,
be
it's fine for
researching
me.
it.
I could hear.
That's a Sanskriti. It was
Very
quite
feeble.
so.
Maybe if you don't mind, can you come closer to the mic
Is my
and
voice
be
audible
quite
now?
well audible
to know who is
and
Sanskriti.
again
There's
repeat
a
the
lot of
same?
background noise behind you. Very well
Is
audible.
my
No,
voice
not at
audible
all
now
audible.
clearly?
Future in our archives we would not
Rajiv,
be
it's fine for
researching
me.
it.
I could
Sanskriti,
hear.
I can hear a lot
Very
of
feeble.
background. Maybe if you don't mind, can you come closer to the mic
Is my
and
voice
be
audible
quite
now?
well
Okay,
audible
sir, wait.
Who is Sanskriti?
again
There's
repeat
a
the
lot
same?
of background noise behind you.
Sir, can
Very
you hear my voice
audible.
now
No, not at
properly?
all
Now
audible.
clearly?
Future in our archives we would not
Rajiv,
be
it's fine for
researching
me.
it.
I could
Sanskriti,
hear.
I can hear a lot of background. Maybe if you
So,
don't
very good
mind,
morning
can
to
you
all present here.
uh,
It's my
be
great
quite well
pleasure to
audible
invite you all to this special lecture on
again
life cycle
repeat the
assessment
same?
methods and tools. Taking the
Sir, can
moment,
you hear my voice
would
now
you like to
properly?
welcome our speaker, Mr. David Kurzweil, who is a scientific researcher at Institute of Sustainability in Civil Engineering. So, very good morning to all present here. I can Germany. Recently, he was selected as the UAE Young Ambassador special lecture on life cycle assessment as one of the 31 individuals from India, Bangladesh, Nepal, and Sri Lanka. He completed his bachelor's in mechanical engineering from Mahatma Gandhi University and master's in transportation and mobility management from RWTH Icahn University. He has worked as project assistant and student research assistant at RWTH Icahn Germany, where he is currently working as a scientific researcher. Without any further ado, let's welcome our chief guest to take on the lecture. University and Masters in Transportation and Mobility Management from RWTH Icahn
Thank you,
University.
Sanskriti, for the great
He has worked as
introduction.
project
So,
assistant and student research
you have
assistant at
already told that I'm the
RWTH
Dardian
Icahn Germany,
ambassador
where he is
and
currently
scientific
working as a
researcher.
scientific
I'm not
researcher.
further
Without
introducing
any further ado,
myself.
let's
Then
welcome our
I will
chief guest to
directly
take
go
on
to
the
the
lecture.
session with introducing the RWTH Aachen University. Hope everyone can hear me and also see my slides. If there is some issues, please feel free to raise your voice even between while I am talking, or you can inform your leader Sanskriti or Raji can also tell me. I cannot see the chat because I have only one screen now. So if there are any questions, directly drop me. Okay. So let me give a brief introduction to the RWTH Aachen University. First of all, and to my institute, and then I will go to the life cycle assessment. So RWTH, so some of the facts and figures. So RWTH is the short form of Rheinische Westfälische Technische Hochschule, and we have also a University of Excellence, which is awarded to the best university in Germany. And RWTH is established in 1870, and with a strong focus on STEM. And there are more than 45,000 students studying in Aachen, with a great percentage of international students, with 14,500. And as far as my knowledge, there are around students from 149 countries studying in RWTH Aachen, as I heard from a officer in the last year. So in the ranking also, RWTH is well placed based on the QS World University ranking 2023. With my knowledge, this ranking, RWTH is placed in the 106th position worldwide, and RWTH is mainly focusing on STEM, and RWTH does not have a strong background in these disciplines like arts or something like that. That's why its ranking is somewhat behind like 106. But if you look into very core engineering, architecture, and this kind of areas, you can see that RWTH are very below from 1 to 50 at some. Yeah, we have also big percentage of Indian students studying in our very core engineering is the second largest sector, and this kind of areas you can see that. And as per the forecast, Indian students will beat the number of Chinese students. I think in the next. Yeah, and you have also increasing percentage of Indian students studying is also very core engineering is the second largest, and also there are a lot of business areas you can see that. Indian professors and Indian students will beat the number of Chinese students. I think in the next. And you have also increasing percentage of Indian students. Other cities also very core engineering is the second largest, and also there are a lot of business areas you can see that. Indian professors and Indian students will beat the number of Chinese students. I think in the next. And you have also increasing percentage of other cities also very and the core engineering is the second largest, and also there are a lot of business areas you can see that. Indian professors, Indian students, FMBA, past Chinese students. I think in the next. And you have also increasing other cities also and the core IIT Bombay, IIT Chennai, we have around 68 Indian students, FMBA, past Chinese students. I think in the and you have something related to planning, IIT Bombay, and we have around 68 different universities. And you have something related to planning, IIT Bombay, we have around 68 different universities. Something related to planning, we have around 68 different universities. Something related to planning, we have around 68 and please feel free to different universities. I'm coming from the Institute of Sustainability planning and I'm coming from the Institute planning and mainly, our researches are in the area of life cycle sustainability assessment, development of indicators, impact categories, circular economy approaches and certifications. So after environmental exploration approaches. Mainly our researches are in the area of life sciences. May I ask development of indicators that categories is my circular economy, the languages and certifications. So environmental exploration approaches. Mainly our researches are in the area of life sciences. May I ask development of indicators that categories is my circular economy, the languages and certifications. Sorry, I couldn't hear you. Environmental
It's okay, we can understand.
mainly our researches are in the area of life. Thank you. If there is any issues, please feel free to raise your hand. Yes, my circular economy. And also, if there are any doubts or anything, sorry, I couldn't hear you. Environmental
It's okay, we can understand.
so, yeah, so mainly our researches are in the area of life. Thank you. If there is any issues, please feel free to raise your hand. Yes, my circular economy. And also, if there are any doubts or anything, sorry, so, yeah, so mainly our researches are in the area of life. Thank you. If there is any issues, please feel free to yes, my circular economy. And also, if there are any doubts or anything, sorry, excuse me, mainly our research. Sorry to if there is any issue.
Slides are not changing.
And also, if there are any doubts or sorry,
Excuse me,
mainly our research.
sorry to
If there is any issue,
Slides are not changing.
please feel free to tell me. And also, if there are any doubts or sorry,
Excuse me,
mainly our research.
sorry to
If there is any issue,
Slides are not changing.
please feel free
Yes.
to tell me. And also, if there are any doubts or can you see the slideshow?
Excuse me,
Mainly our research.
sorry to
If there is any issue,
Slides are not changing.
please feel free
Yes.
to tell me. And also, if there are any doubts or then I is it okay to share? Can you see the slideshow like this? Can you
Excuse me,
mainly our research.
sorry to
If there is any issue,
Slides are not changing.
please
Yes.
to tell me. And also, if there are any doubts or
So can you please show the previous
like this?
Excuse me,
Mainly our research.
sorry to
If there is any issue,
Slides are not changing.
because we didn't
Yes.
solve that. We were on the
doubts or
So can you please show the previous
I have already asked you this.
Excuse me, sorry to
If there is any issue,
Slides are not changing.
because we didn't
Yes.
solve that. We were on the So
I
can you please show the previous
have already asked you this.
Excuse me, sorry to
If there is any issue,
Slides are not changing.
because we didn't
Yes.
solve that. We were on the yes. So can you please show the previous
I have already asked you this.
Excuse me, sorry to
If there is any issue,
Slides are not changing.
because we didn't
Yes.
solve that. We were on the yes. So can you please show the previous
I have already asked you this.
Excuse me, sorry
Feel free
to
to raise any issue.
Slides are not changing.
Just in your generation.
because we didn't
Yes.
solve that. We were on the yes. So can you please show the previous
I Systems such as ISO Type 1, Type 2, Type 3, Puff EPD lead. I don't know. Maybe you are familiar with lead. Are some of you are there someone who is familiar with lead certification?
Yes, sir.
All this? Okay, good. So because I don't know much about lead. I am from an Puff EPD lead. I don't know. Maybe you are familiar with lead. Are some of you are there someone who is familiar
Yes, sir.
with lead? Yeah, certifications. I think most of you are from the architecture background.
Yes, sir.
All this? Okay, so let's start because I don't know much about lead. I'm from an Puff EPD lead. Life cycle sustainability. Maybe you are familiar with lead. Are environmental, social, and economic lead. So how do you assess this environmental impacts, social impacts? Okay, so let's start because I don't know much about lead. I'm from an Puff EPD lead. Life cycle. Maybe you are familiar with lead process, which is environmental, social, and economic lead. How do you assess this the social life cycle or this? How do you okay, so let's start because I don't know much about lead. I'm from an EPD life cycle. Maybe you are familiar with these are the three processes: environmental, social, and economic. When you say sustainability, how do you assess this the social life cycle or how do you say so? Let's start because I don't know much about lead. I'm from an EPD life
Maybe you are from mobiles or the product or social that you have technology and how do you how only that or a service so let's start how I don't know how to manage that maybe you are from mobiles or the product or social that you have technology and how do you how only that or a service so let's start how I don't know how to manage that maybe you are from mobiles or the product or social that you have like only that forward or a service so let's start how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the different only that what is like how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product extraction to raw
only that what is like how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product extraction to
only that what is like how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product extraction to
only that what is like how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
only that what is like how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
only that how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
only that how I don't know how to manage that maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
only that so about the sexual maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
only so about the sexual maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
so about the sexual maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
so about the sexual maybe you are from mobiles or the product or lot of definitions of the
Sir,
different
if we consider a product
so about the sexual maybe you are from mobiles or the product or lot of definitions of the different
Sir, if we consider a product
so
Stages into consideration. We will not say when you do the life cycle assessment, we are not just considering the use stage of that battery electric vehicle. We are not just considering the production, how much environmental impact is caused by production. No, it's not the life cycle assessment. If you want to do the life cycle assessment, you have to consider from its beginning to its end. So that is life cycle assessment. Okay, that is what INAB is mainly doing. I will explain more detail later. So these are the main our partnerships where we are partnered in our projects. Also, let me also just give a brief idea of what I am doing in INAP. So European Commission want to have by 2027, they would like to have a European, sorry, environmental footprint label and a social footprint label on the cars, on their cars, which are going to be sold from 2027. So when the European Commission makes it mandatory to have this environmental footprint label and social footprint label for all the cars, the OEMs, original equipment manufacturers, or the companies who are manufacturing these battery electric vehicles or whatever, or whichever vehicle, they would like to have a guideline or a framework how this environmental impact should be measured, how the social impact should be measured across the life cycle. So actually, I am developing this guideline for almost all the OEMs of Europe who are involved in the automobile manufacturing. So almost all the automobile manufacturing in Europe are my partners from whoever you say BMW, Ford, Scania, Volkswagen, Iveco, Volvo, Toyota. So all of them are involved in this project, and they gave me data, and I together with my other partners build a framework and a guideline, and we will take their opinion, and also there are also people from policy level. So we have a together discussion with the policy level, academic level, and also academia. So we have a discussion together and build this guideline for OEMs to measure their environmental footprint and social footprint of their zero emission vehicles. So this is a rough introduction to my institute, INAP, and also the RWTH Jharkhand University. Then we can jump into the detailed knowledge of the life cycle assessment. Before that, I would like to ask, are there any, would you like to know anything more about RWTH Aachen or about Institute of Sustainability or about my project or about me, what I'm doing or anything, please let me know. So this is the time. Feel free to ask, please.
Yes, sir.
Yeah, please, go ahead.
Good evening, sir. Actually, I had a doubt about your project as you were mentioning. I just wanted to know, like, what was the approach, like, what kind of approach you are like taking ahead for the framework. Can you please like let us know about that?
Sorry. ISO standard is a vague guideline. It's just give a brief idea, and it cannot be applied to any particular product or process. But if you want to apply to a particular product or
framework which is proposed in ISO 14040. ISO 14040 gives a brief idea how to do this, a basic guideline and format how to do this, but it does not precisely tell how it should be applied for each of the product. And also, what is the main motivation for European Commission to have this label is that because as a customer now I am living in Germany and I don't have a car now, and when I am planning to have a car, I would like to have a battery electric vehicle, of course. And then I go to a showroom which has a huge collection of cars from a lot of companies and a lot of models. As a sustainability passion to sustainability, I will check which label has, which car has or which model has in the same segment has least environmental footprint or social footprint. In order to have, in order to have that comparison, every OEM should measure their environmental impact or social impact basing on a common guideline or a common standard, right? So that is the main motivations to have a harmonized approach for OEMs to measure their environmental impact. So they can just use the ISO standard, but when they just use the ISO standard, it will not be harmonized. There are a lot of points that have to be considered when you do the life cycle assessment, which I will show you later. So if the OEM, different OEMs for different cars or different models, they are considering those characteristics of life cycle assessment in a different way, I cannot compare the results. If all the process behind that they have calculated are same, then I can compare the results, right? So that's why I'm making this. Is it clear or is it the answer to your question?
Okay, sir. Thank you, sir.
Yeah. Are there any other questions? Feel free to ask. Are there any questions related to RWTH option? How you can join for master's or PhD or anything? Or we can discuss those things later at the end of the session. Okay. Just to mean that there are no more questions, I'm just skipping to the next PowerPoint. Oh, someone was just switching on their microphone, I think. Are there any questions? Okay, let me continue. So I have given you a basic idea of what is life cycle assessment. Is that clear to everyone what is life cycle assessment? Do any one of you have any doubt related to life cycle assessment? Feel free to ask. Are there any small doubt? Please feel free to ask. Okay. With the hope that it's clear for you what is life cycle assessment, I'm just moving on. Yeah, we have already talked about life cycle assessment. So based on the ISO 14040 standard, this ISO, based on this framework, environmental assessment framework, there are 4 phases for life cycle assessment. The first phase is Golan scope definition, and the second phase is inventory analysis, third phase is impact assessment, and fourth one is interpretation. These 4 aspects we will be detail looking today. Okay, and there are also several terms and definitions that you can see in the ISO 14040 2006. When you look into the ISO 14040 2006, maybe through your university access, it will be possible for you to access this ISO standard. So there are a lot of terms that you will be seeing while scrolling through this document. So I will talk the most important ones. I'm not going through each and every one. So let's say elementary flow. So are you already familiar with elementary flow?
No, sir.
Mhm. Okay. So when you, so why, what is an environmental impact? How it causes? So environmental impact usually causes that something is taken from the environment and something is going to the environment. So It is just the start and beginning of any product or process or any organization, or whatever it is. So as an example of the battery electric vehicle, and the cobalt is mined from the earth. So it is some material that are directly entering from the environment, and that is emitting to the environment. What are the things that are emitting to the environment? So there can be emissions to air, there can be emissions to soil, there can be emissions to water. So starting and end phases, or whatever, whenever there is a direct contact with the environment, that are called the elementary flows. There are a lot of elementary flows that you have to consider in the environmental impact assessment, and the elementary flows are the key flows that causes the environmental impact. So elementary flows are the main flows. What is product flow? And product flows or elementary flows are different. Products entering from or leaving to another product system are called product flow. So all the technosphere flows. Now, what is the technosphere flows or economic flows or product flow? All the flows that are happening after that you have taken from the environment and before that you are emitting to environment are called product flow or called technosphere flow, or you can also call it as economic flow. And between this product flow, there are also intermediate flow, which are between the unit processes. When you want to do a life cycle assessment, you have to draw a system boundary, for example. So let us just compare the carbon footprint, which is an indicator of life cycle assessment. So life cycle assessment have a lot of impacts. So one is global warming potential, right? Which, yeah, other impacts we will see later. Just to understand what is system boundary, you want to you might be saying the walking is more has less carbon emissions compared to using an IC engine vehicle, right? Do you agree with me? Walking
Yes.
walking has less carbon footprint than using an IC engine vehicle. Okay, but let's say when you walk, when you are walking, what are the inputs and outputs there?
Heat.
Sorry.
So
Okay.
it's just kinetic heat. The energy is transferred.
Yeah, so its energy is transferred. Yeah. Then what are the inputs for energy? What is input for energy? It's food, right? We need food, and you need chapel, maybe shoes for walking, maybe without shoes. Yeah, but just consider, for example, right? So maybe for you have to build a pathway for walking. You understand? Are you getting my point? So in this case, maybe so I am taking the input as food, and where this food is coming from. Maybe for growing this food, you need fertilizers. So how these fertilizers are produced? It is in a huge factory with the electricity that is produced from coal. So that such that you can go behind and expand your system. But you have to draw a system boundary. Maybe you can just consider walking as a zero emission mode of transportation if you are just considering the walking and not the food and going behind that. Are you getting my point?
Yes.
Okay. So could you please explain what you understood as a system boundary?
So it's
Sorry if
basically
I,
about.
yeah, yeah.
Sorry, sorry. So
If
it's
you are free,
basically.
please you can just answer. Otherwise, I'm not compelling you. Sorry if you felt bad while I'm asking.
No, sir. I'm so sorry. Actually, I was saying that it's basically similar to how you scope down your studies. Like, what are the set of elements you're thinking about, like, for defining a study scope? It is
Yeah,
similar to
exactly.
that.
It's a part of the scope. Yeah, exactly. It's a part of the scope of defining system boundary. So you have to set a boundary to your study always. Otherwise, it's just expanded, and to go until the end of the world. Yeah, so that is system boundary. And what is an impact category? So global warming potential is an environmental impact category. And if I say social impact subcategory is child labor. So these are some of the examples of impact category. Could May I ask you other environmental impacts that are causing or that are happening now, other than global warming or climate change? Which are the other impact categories that you know, or environmental impacts that you know?
So the reduction of fossil fuels.
Energy, resource utilization, right? Yeah.
Yes.
Okay. Another. Yeah, resource use is a good example, and it is the right example from the life cycle assessment perspective. And other examples are eutrophication, acidification, ozone depletion, and there are a lot, right? Land use, which is very well related to you. Yeah, so these are some of the environmental impacts category. And another thing is the characterization factor. I will explain in detail later with an example and also the allocation. So there based on the ISO definition, there is a phases versus stages. So when you talk in life cycle assessment, there are four phases for life cycle assessment. So this is also a basic knowledge of life cycle assessment. Please remember this at least this take this away from after this session. So there are four phases: goal and scope, inventory analysis, impact assessment, and interpretation are the four phases of life cycle assessment. And you can see an arrow mark to and forth between all the four phases. Why it is so? Because it is an iterative process. Because after defining some of the aspects of goal and scope, you move to inventory analysis. Then you identify, okay, some of the aspects in the goal and scope are missing, or it have to be changed or tweaked, something like that. So it's back and forth. Or after impact assessment, you will identify what you defined in the goal and scope, how to have to be changed, or whichever data that you collected in the inventory analysis, how to be changed, something like that. So it's an iterative process always. That's why you are seeing an aroma to and forth between the four phases of life cycle assessment. So the four phases of life cycle assessment, which are goal and scope definition, inventory analysis, impact assessment, and interpretation. Okay. Please remember these four phases. And the different stages of life cycle assessment are extraction and upstream production. So these are the different stages. When you say extraction, upstream production, manufacture, use, disposal, recycling, and in between all of these processes, all of these stages, there are transportation. Maybe they are in the same factory, then you do not have to transport, otherwise you have to a stage that is with the transportation. Okay. Are there any doubts related to this phase and stages? Okay. Just moving on to so why do we need an LCA? So you are here for LCA lecture, and there are four main reasons why we do an LCA, life cycle assessment. Why our organizations do this? Why people do this assessment for their product or their processes or their services? Why they are doing this? Because you know that it's a major issue to the world now is the climate change, and the climate change is a global issue. And especially since I am working with the European Commission, I am well aware that European Commission has a leading role in the world to compete against climate change and also to compete against the environmental impacts. So with the life cycle assessment of products, processes, whatever, so we know that where is the problem. So when you look at the life cycle perspective of a product, you will get to know that in which stage of a product that you have the problem of a particular environmental impact. So let's say now we are with this huge climate change issue with global warming, with the greenhouse emissions. I'm not sure how you are feeling in Vijayawada. Currently, I am in Kerala, and it is too hot for me, and I cannot stay alive, and I'm facing a lot of difficulties with this increasing heat waves. So we know that it's a very huge problem, and we are not taking it seriously till now. And it is now a later stage of it. You have to make sure that your carbon footprint is as less as possible. You have to take actions towards that. It's a global issue. So one country or one society, if they take some actions, they cannot solve it. We have to take this seriously in a together way, together in an umbrella. So please, I request you, or humbly requesting you, please to take serious actions in your lifestyle to reduce your carbon footprint. So by doing the life cycle assessment, you can identify the processes where you have the highest amount of greenhouse gas emissions, and thus you can reduce or you can take actions like eco designing or another changing the processes or changing the product or changing the material or changing the location or changing the electricity type or whatever to improve its environmental performance. And LCA results also help decision makers. So I'll say if you are working as a sustainability manager tomorrow in a company, you will ask your subordinates to do an LCA for the product of your company, and they will provide you with the life cycle assessment result of some of the impact categories like global warming, climate change, as student heard, resource use, eutrophication, acidification, and you see that for all of these environmental impacts, your product has a very high environmental impact. Then, as a decision maker or as a strategist for your working for your company, what you have to do with the increasing laws for environment and a worldwide recognition of companies who are sustainably well advanced. As a person who would like to have a good fortune for your company, you would like to you will take decision according to this LCA results and make changes in your product life cycle such that it can reduce the climate change and so on, so environmental impacts. And also this LCA helps to identify the relevant indicators of environmental performance. So if there are some of the, when you do the life cycle assessment, there are a lot of ways to do it in different softwares. And when you do this life cycle assessment, you will have a very large list of environmental impact results, and you can identify which all major environmental impacts that you have for your product. So there may be 16 impact categories, 16 environmental impacts. You will get the result of 16 environmental impact results of 16 environmental impact after the life cycle assessment, and we can get to know that from the 16 environmental impacts, which are the main environmental impacts that is caused from my product. So based on that, you can solve the issues at the process unit process level. And also you can use the life cycle as if some of the company. So latest the Polestar, which is a car BEV, battery electric manufacturing company. Polestar is a model, and they have published their life cycle assessment result, and they have a pretty much lower climate global warming potential compared to other cars. So they can use this as their marketing label. So they can market there. So their life cycle assessment results are far better than some other cars. They can use this as a marketing tool. But this is also the major reason that European OEMs, the automobile OEMs, are using or building this with the environmental footprint label, which I am working on, so they can maybe compete with the Chinese companies. The Chinese companies which are now top based on the selling, like BYD. You have already heard that BYD, which is a major Chinese automotive manufacturer based on battery electric vehicles, have already overtook Tesla based on selling in China, and maybe after the European Union have implemented this label for the European cars, they could use this label as their for marketing, and they can take back their markets again. Is it clear? Are there any other doubts, or do you have some other examples? Why do an LCA? Hello, people out there.
It's clear, sir.
Okay. Thank you, Pradiksha Thakur. Says one is so. What does an LCA do? Maybe you might have some misconceptions on LCA. So please take into account these points. So they does not measure product performance. So it's not product performance, it is the environmental assessment. Does not address compliance with environmental laws. No, they are not complying. They are not for compliance with the environmental laws. Maybe it might be a tool to check whether the products are compliant with environmental laws, but it is not to address compliance with environmental laws. Does not include analysis on support personal needs, does not normally measure building space conditioning, no, does not include minor inputs, does not provide information about employee direct impacts. It's not a risk assessment analysis. It's not a risk assessment analysis, which is one of the important point. Does not define specific course of action to take. It does not say what to take, what action to take, but it says where the action should be taken. So here is a graph which you can see with the three stages as we are considering production, use phase, and recycling. So we have here three concepts: concept A, concept B, and concept C. When you look into the production stage of that product, you can see that so here we are considering emissions. Let's say it's greenhouse gas emissions. Okay. So when you're considering the production stage, you can see that the greenhouse gas emissions embedded in the product is lesser for concepts lesser for concept C, and it is higher for concept A. And but when it comes to the recycling, it is higher for concept C and less for concept B. And for the use phase, we have to integrate the value. So that's why it's important. Maybe some companies they may argue that based on their environmental impact assessment, their product is the best. But then you have to check whether it is the result of life cycle assessment, or they might be just making you fool by just considering the production stage, or just by considering the use stage, or maybe just considering the recycling stage. So you have to very well aware that when some companies or some products reporting their sustainability result, when they publish sustainability result, what all things that you have to check? What are the three things that you have to check when a company claim that they are sustainable? Can someone? What are the three pillars of sustainability? What are the three pillars of sustainability? I was talking at the beginning of the session. So the three pillars of sustainability.
Sir, economic, environment, and
Yeah, social. So when some company, thank you, Soham Mishra. So when some company claim that they are sustainable, they should be socially sustainable, they should be environmentally sustainable, they should be economically sustainable. Otherwise, they cannot use the word sustainability, and they are making us fool. Okay, please post in who are reporting that their company is sustainable. You have to ask them back whether they are sustainable in all of these three pillars. Otherwise, they have to say environmentally sustainable. Otherwise, they have to say socially sustainable. They have to say economically. Then it's fine. Okay. Yeah. Then coming to this ISO 14040 background. So this ISO 14040 is the environmental management, life cycle assessment principles and framework. And under this ISO 14040, there are a lot of other standards that are coming on, which is ISO 14044, which gives the requirements and guidelines to do life cycle assessment. And also you can see that ISO 14047 gives an illustrative example on how to apply this ISO 14044 to impact assessment situations. Then there are also 14,071, 14,048, and so on. Recently, my professor Macia Travoso is working on ISO 14,075, if I am correct, or 74. I'm just not remembering the exact number. So my professor is the convener for developing the requirements and guidelines for social life cycle assessment, so which is a new concept. So this ISO standard might be published by the end of this year or by the beginning of next year, I hope. So this is ISO background of ISO 14040 and 44, and ISO 14040 and 44 are mainly cited in all the journal papers, those related to life cycle assessment. And if you are also more interested to learn life cycle assessment, please refer first to ISO 14040 and ISO 14044. So, in the scope, based on the scope of ISO 14040, what are the four phases of life cycle assessment? Can someone? Which are the four phases of life cycle assessment?
So the first one is goal and scopes. Second is inventory analysis. Third is impact assessment, and fourth is interpretation.
Yeah, thank you, Pratiksha Thakur. Yeah, these are the four phases of life cycle assessment. And other than the phases of life cycle assessment for 2040 ISO standard have also given directions on how the results should be reported and it is critically reviewed, and how what are the limitations and how it should be uh, reported. What are the relationship between phases? I have already mentioned that it is an iterative approach, and it is all the phases, as Pratiksha Thakur mentioned, are related to each other, and also conditions for use of the choices and optional elements. Pratiksha, do you have any questions?
No, sir.
Okay, thank you. Yeah, then I will go into detail to all of these four phases of life cycles. So, in the goal and scope, which is the phase one of life cycle assessment, so goal statement is the first component of an LCA. So, whenever if you would like to read more on LCA, also you might be looking into the journals related to life cycle assessment of the product or process or service which you are working or studying in your master course. So when you look into this journals, this goal statement might be the first component that you will be seeing. So what, and this goal component must state the intended use of the study, the reasons for carrying out the study, which are the target audience that the study is looking for, and whether this study, life cycle assessment study, is comparative and it should be disclosed to public. So these are the four aspects that need to be there when you define a goal. You just can't say that this is the assessment of, let's say, battery electric vehicle, environmental assessment of battery electric vehicle. No, it is not the goal of the study. When you define the goal of the study for the life cycle assessment, so these are the four aspects that you have to consider. Maybe this definition of goal you can also use in your master thesis, right? So whichever area, I think this is a very good example how you should write a goal. And when it comes to the scope provides the background information, detailed methodological choice, and lays out report format. So you can see different components that are under scope: product system, functions of the system, functional unit, system boundary, allocation procedures, impact categories, assessment method and interpretation type, data requirements, assumptions, limitations, initial data quality requirements, type of critical review, type and format of report. So there are a lot of components that should be included under scope. And all of this have to be there mandatorily asked per the ISO standard. So earlier, Pratiksha have asked me a question. So why I want to do this? So here you have seen that there are a lot of components that are coming under goal and scope, right? Let's say I want to buy a car and all the OEMs, original equipment manufacturers, are considering or defining all of each of these components of goal and scope differently. I cannot compare them, right? I cannot compare the final result. And different car have defined different product system or different system boundary or different functional unit, different assumptions, different allocation procedures, different impact categories, different assessment method. I cannot compare them, right? So that is why it is important that it is to make a harmonized standard that's such that all the OEMs can apply to their product and I can compare them. Is it clear now more, Pratiksha?
Yes, sir.
Sorry, should I call you Pratiksha or Thakur?
So Pratiksha will be fine.
Okay, thank you. Yeah. Yeah, so that's why I am doing my project and it is requested from Europe. So here you can see an example of a slab. So slab is my product. Just say so. Slab is my final product that I am using, and I am the sustainability manager of this slab producing company, and I am asked to do the life cycle assessment from the managerial board for the slab. Then first of all, I am finalizing the goal. So what are the components that goal should have? It should have the intended audience. It should have the reason for the study. It should have the target audience, and I have to say whether this is for comparative or this is for the and this is for the public audience. So such that I have defined the goal, and then I have to define the scope. And in the scope, I have to say which is a system boundary. Just one of the components. Let's say. So here you can see which is my system boundary. Uh, so the outside this thick line is my system boundary, and all the processes, including this transport of scraps, monoblade gangs or multi-blade gangs or block cutters. So again, transport egg polishing machine, slab polishing machine, marble chip flow files and slabs. All of this, all of these processes are included under my system boundary. So from the quarry, you know that how a slab is produced, right? From the quarry, it is maybe either cut out by monoblade gangso or by multi-blade gangso. And after there are a lot of procedures, milling, drilling, polishing, transportation, use of electricity, emission to water, emission to soil, there are a lot of components. So all of these processes coming under this system boundary. We can see the thick outside line, right? So coming under this thick line is will be considering in my study. Are there any doubts related to system boundary? Maybe may I ask? Uh, so you most of you are of the architecture background, right? Or can someone tell an example of the system boundary of a product or a process that you are looking to? Just try. I can help you. No worries. If you don't understand, I can just make it more clear. That's why I'm just asking. Someone come forward. No worries. If it's wrong, completely fine. Take the challenge. No issue. Don't worry. Okay. It means that it is not clear to. Maybe I will explain it once again with this example of this concrete example of this concrete building. So here I'm so my task is to do the life cycle assessment of the concrete permit. So in this, I have if I have divided all the processes of this concrete permit into three, like A1, A2, A3, it doesn't matter. It's just for to understand. So under A1, I have considered the raw material acquisition, cement making, water withdrawals, fuel production, electricity generation, everything under my A1. And A2, the transportation of this after the cement manufactured, it is transported to manufacturer, and it is packaging aggregates for cement, and then there might be waste, and also the packaging is produced, so it is also considered under my study, and the mixing with water is also considered under my study. So here, whatever I have considered for producing this cement, or the concrete, I have considered the mixing with water. I have considered the packaging of this cement. I have considered the waste treatment of this package cement. I have considered how the cement is manufactured for the fuel production. So the fuels are needed, right, for the cement, maybe petrol, diesel, or whatever it is. I don't know what are the things fuels that are needed for cement. The water that are considered, the raw material acquisition, that means extraction, raw material extraction is considered, the fuel production is considered, electricity generation is considered. So all of this process are again considered in the system boundary for the concrete permit. So again, here is the system boundary of cement. So all of this process, let's start from the production process, like limestone quarry, and from the limestone quarry it is crushed, and the fuel and raw materials are used. Gypsum, aluminium are some of the raw materials, and then it is fed into the petcock mill, and it is for fuel, and the clinker is stored here, and finally it's filtered and all, and finally you will get the mixture of this concrete, and then you dispatch. All of these processes are considered, and life cycle assessment is not an easy process. You have to consider all the inputs and all the outputs related that comes under your system boundary. You just can imagine how much inputs that you have to produce a single product, right? For just making a battery electric vehicle, you have thousands of processes, thousands of inputs, and thousands of outputs. You have to collect all those data. I will come to that detail in the life cycle inventory steps. So it's a very complicated process. And other than system boundary, another one characteristic of scope, when you define scope, is the functional unit. A functional unit is defined as a utility, the role that the product plays for its consumers. So what is a role that plays by a building? I assume that most of you are architect. Sorry if it's not, but there might be some of you, right? So maybe if you are doing a life cycle assessment for your building, based on the definition here, a utility, the role that the product plays for its consumers, what might be the function of your building? What is the function of the building?
Sir, it depends on different typology of building.
Sorry?
It depends on different typology of buildings. Like if it is a residential building, so or it's a commercial
Okay.
building.
Okay, just let's say you are doing the life cycle assessment for a residential building. What might be the function of the residential building?
So it includes all the livable space within that building.
Is it the function of the building? Function of the residential building? The function of the residential building. I am not the expert of building. You are the expert. I'm just making. For example, from my perspective as an automobile researcher, the function of automobile is to travel from one point to another. So, in that perspective, what might be the function of the residential building?
So it's to provide shelter.
Just to provide shelter. I also think so. I don't know. Maybe you have some other definition of functions, but basically, as a common man from my side, as my side, with not much aware of this building thing. Yeah, just to, as a common man, I think a building is to provide shelter. Let's say that's a function, right? This function has to be defined in the LCA study. Maybe it might be different for different people. That's why I have told it's very mandatory to harmonize for a product when you need to compare. That's what I'm doing again. So now we are going to define the functional unit for a building. So there are some points that you have to remember when you define the functional unit. Functional unit is just a unit that you have to base. Finally, you will have the global warming potential of your building, right? So based on what unit that global warming potential is, that is this functional unit. So when you define this functional unit, you have to describe the product by its properties, including the product social utility. You have to determine the relevant market segment. You have to determine the relevant product alternatives. You have to define and quantify the functional unit in terms of obligatory product properties required by the relevant market segment. You have to determine the reference flow for each of the product systems. So these are the steps to how to follow to define the functional unit. Uh, for example, I will. So here we have an example for the slab, which we are considering the marble slab. The unitary volume 1 meter cube of marble has been chosen as the functional unit. So because therefore all the impacts that we will be measured at the life cycle impact assessment phase will be based on this 1 meter cube of marble. And when you define this functional unit, you can take into account the functionality, technical quality, additional services, aesthetics, image, cost, specific environmental and social properties, and so on. For example, when you are to assessing again, another example, when you are assessing the life cycle, when you are doing the life cycle assessment for a battery, so you will be the functional unit will be a 1 kilowatt hour that the battery can provide. So this can be a functional unit when you do the life cycle assessment of the battery. And when you do a life cycle assessment of an automobile, the functional unit can be the 1,000 distance traveled by a car. So all the life cycle assessment result will be based on the 1,000 kilometer that the car has traveled. Yeah. Again, the reference flow, when you want to get a result, so the final process that translate or the final flow that translate the abstract functional unit into a specific product flow for each of the compared system, so that the product alternatives are compared on an equivalent basis reflecting the actual consequences of the potential product substitution. So this is a reference flow. uh, a unitary volume of marble, 1 meter cube is the functional unit, but the unitary volume of marble. So this is the reference flow of your product. Again, you have a lot of inputs and outputs, and this inputs and outputs are finally comes into the flow of the unitary volume of marble. Understand? So you have a lot of inputs and outputs, right? From different processes or different stages from raw material extraction to the end of life. At each stages, for example, raw material extraction, manufacturing, end of life, use stage. At each stages, you have a lot of inputs and outputs, and lots of inputs and outputs are finally combining to a final flow, which is reference flow. And based on this reference flow, that is your final flow. You are doing your life cycle assessment based on that flow. That is reference flow. Well, for example, based on your building, so final you will be having, let's say you will be telling it's a square meter, right? Maybe based on a square feet. Normally, we will describe the area of a building. So the final flow of a reference flow of a building, when you do the life cycle assessment, maybe 1,000 square feet of building. So all the inputs and outputs that are gathered for the 1,000 square feet of building, and it is finally come to the reference flow of 1,000 square feet of building. So that you will collect all the inputs and output data based on this reference flow. And again, you have to give the description of the product life cycle from raw material extraction to the end of life. So how it is from where it starts and how it is transformed, how what is milled and how it is drilled, and so on, so on, so on, so on, step by step by step by. So it's a last process. And then coming to the phase two, which is life cycle inventory. And life cycle inventory has data collection. And mainly all the inputs and output data as far as possible is collected under this phase. So now you have already defined the goal and scope. You know what is the goal of the study. You know what is the system boundary of the study. You know what are the unit processes that you are considering for your study. You know what is the functional unit. You know what is the function. You know which all impact categories that you are going to measure. These all things that you have already defined in the goal and scope. Now we are going to collect all the input and output data based on your functional unit, based on your system boundary, based on your impact categories, all that you have defined in the column scope. Is it clear? Are there any doubts related to the column scope? Any doubts? Feel free to interact with me. Are there any doubts related to column scope? Alright. Yeah, please. Soham, sure. Soham?
No, sir, there is no doubt actually. I was saying.
Okay. Fine. Is it clear for you? Are you following? Are you following?
Yes, sir. Maybe, sir, one more example would be convenient. Actually, we are getting, but not that much properly. Uh,
So where you are missing or
so
not
the main,
following?
uh, so like the part when you asked about taking an example, if we take the brick manufacturing as one of the example, sir, how to do the first phase. Am I clear?
What manufacturing? What is
Uh,
your
I,
problem?
brick manufacturing industry.
Okay. Okay. So if you are manufacturing a brick, you have to first understand what are the raw materials that you are needed. Okay. So you
Okay.
are just so what are the raw materials needed for brick?
Um,
Just any raw material.
Clay, silica.
Okay. Okay, just say clay silica. So the clay and silica are the two materials that are needed for manufacturing a brick. And and when you find you are first describing all the stages that you need to consider in your life cycle assessment study. That is a system boundary. Do you want to include the raw material extraction of clay and silica?
Yes, sir.
Okay, let's start from then raw material extraction. And when you do this raw material extraction, how you do this raw material extraction? You would use some machines, right?
Yes, sir. Machine
Okay,
labor
then
and all this.
yeah, you so labor. I think it's not in the consideration of environmental impact assessment. It is mainly under social impact assessment.
Okay.
Okay,
Okay.
Most of the technical aspects of the product life cycle are considering under environmental impact assessment. Okay,
Okay.
where there is a direct connection with the environment and not with labor or with the social aspects. Yeah, when you want to do this raw material extraction, you want to know what are the machines that you are using and how these machines are powered. Maybe it is powered by using diesel or petrol or by using the electricity. Then you have, so this is an input. The electricity is an input there. So when you do the life cycle inventory, the phase two, you have to understand how much electricity is used to generate to if you are having one brick, you are if you are doing only the life cycle assessment of one brick, then you have to see how much electricity is used to mine the clay or silica for this one brick. So this is an input. Yeah, then you have to
Okay.
also understand how much maybe you by using this electricity, maybe if this electricity is from coal, you have to understand how much greenhouse gases, for example carbon dioxide, is emitted to atmosphere to mine this amount of clay to manufacture one brick. Okay,
Okay. Yeah.
similarly water, how much water is needed for to extract clay for one brick. So one brick, understand? One brick is
Yes,
your
sir.
functional unit, and
Got it.
one brick is also your reference flow. So you are collecting all the inputs and output data based on this one brick.
Okay, sir.
Is it clear?
Yes, sir.
So similarly, you have to do this for all the inputs and outputs at all the different stages of the life cycle.
Okay.
Yeah. Is it clear, Soham Mishra, or still you are missing something?
No, sir. It's clear. Thank you.
Okay, thank you. Maybe since Pradiksha was also interacting, may I also ask you, Pradiksha, is it clear for you?
Yes, sir.
Okay, are there any doubts for you?
No, sir.
Is it, are you good with the Golan scope definition now?
Yes, sir.
Okay, perfect. Then let's go to the next life cycle inventory. So the life cycle inventory is just collecting all the input and output data. I will show you an example for you. So these are the step-by-step procedure of life cycle inventory analysis. So you have to collect the data based on a data collection sheet. Then you have to validate the data. Then relating data to unit processes. So all the data that you have collected, you have to relate with all the unit processes. Unit processes means milling, drilling, whatever it is, it comes. All of these are unit processes. Then you have to relate all the data to functional unit. As I have told the example of one brick, you have to connect the amount of clay that you have mined to the functional unit, or the amount of electricity used to the functional unit. Then the data need to be aggregated and refining the system boundary. So if you have not enough data of some of the unit processes, then you have to adjust your system boundary in such a way. And these are some of the inputs and outputs. So here, this is a system boundary, and you can see many inputs and outputs here for a car. So for the cars, you can see here raw material is extracted, then the materials are produced, then the final material is produced, and final product is produced here. Then it is used and it is maintained. Then it is going for recycling or it is going to dispose. And under this, there are a lot of inputs like energy, electrical energy, mechanical energy, thermal energy, lot of raw materials, lot of intermediates, lot of auxiliaries. These are all the inputs, and lot of there are many outputs like waste, wastewater, waste heat, residues, co-products, emissions into air, emissions into water, emissions into soil, and also there are also overburdens. So these are some of the examples of inputs and outputs that you have to collect while doing the life cycle inventory. There are also different databases that helps, so that you have already have all the inventory data that you might have. So some of the mainly used database is EcoInvent database. EcoInvent. Please note it down if you would like to do this life cycle assessment. EcoInvent. EcoInvent is a commonly used database, and another database which is developing by European Commission now is EF database, Environmental Footprint Database, and there is also another one database which is developing by the United Nations, which is GLAD, GLAD. You can look into these databases. With maybe you will get enough data that you can do the assessments. So this is an example of the data collection sheet for collecting the data for the unit process. So here you have a column with material inputs, and material inputs can be cobalt, lithium. So in your case of brick, it can be clay, it can be silica, and then you have to write the units of how it is, how you collected it. Then you have to write the quantity and description of the sampling procedures and its origin. So water consumption, energy inputs, material outputs. So this is an example of how of data sheet for collecting the data for unit process. And again, the example of data sheet for upstream transportation. You know what is upstream and downstream? Someone know? Upstream collection, downstream collection. So all the processes that are, someone want to answer? Okay, so upstream processes and downstream processes. All the processes in a product life cycle, that is from the raw material extraction to the manufacturing in the plant or upstream, and from the all the processes after the production, after the manufacturing till the end of life is the downstream. So just until the plant of manufacturing it is upstream, and after the manufacturing it is downstream. So this is an example of data sheet of how to collect the data for the upstream transportation. So for upstream transportation, so you have to collect the kilometer and the truck capacity, the actual load, and the empty return. So how much distance the truck, if the transportation has taken place by truck, you have to see how much distance it is calculated. What is the truck capacity? If you need different trucks have different capacity, loading capacity, you have to take that into account. Then you have to see how much the trucks are loaded. Then you have to see whether it is whether the truck is returned back with an empty load or it was loaded. And this is also, sorry.
Sir, can you repeat the upstream and downstream explanation once more?
Yeah, sure. Thank you for asking. So all the upstream process, all the process in a product life cycle, from raw material extraction until the manufacturing of a product, are upstream processes. So it's going something upward. Just remember that. So if you are extracting a material, it is taking from ground and it is going to some manufacturing unit, right? So it is something upstream. Hello,
Yes, sir.
you understand now what is
Yes, sir.
upstream
Yes, sir.
process?
Yes, sir.
And after that, it is going from manufacturing plant to the end of life, again to ground. So it is again from top to bottom, right? So again, it's downstream. Is it clear, prediction now?
Yes, sir. Thank you, sir.
Okay. Yeah, again, the example of data collection sheet of unit processes. So now here it's a data collection sheet for outputs. So in the outputs, there are emissions to air, which you can see emission to air. What can be? It can be carbon dioxide. How you what which is the unit that you use to collect the data for carbon dioxide? How much quantity? and description of the sampling procedure. Again, emissions to water, emissions to land, and other releases. You have to get the unit, you have to write the quantity, and you have to also describe the sampling procedures. So here you can see a structuring of LCI inputs and outputs of life cycle stages. So in the first column, there are carbon dioxide, NOx, phosphate, and different outputs you can see. And again, there are kilogram, how much material is processed, in the different stages. In the material production, how much is emitted. In the manufacturing process, how much carbon dioxide is emitted. In the use phases, how much, and other. And the total, you can see that 6,750 kilogram of carbon dioxide is emitted, for example. So this is how you collect the LCI inputs and outputs. Is it clear for the life cycle inventory?
Yes, sir.
Okay, thank you. Yeah, again, with an example of environmental life cycle inventory of quarry, you can see that in the quarry, in the extraction of marble, you need electricity, you need explosives, you need water. These are the inputs, and the outputs here are spoil and flowing back. And this marble block are then transported for squaring phase. And in the squaring phase, you again need as inputs electricity, diesel oil, and water. And outputs, you have the scraps and flowing back. And these blocks are again transported. And for transportation, again, you have their diesel as input. And you also know that while it is transported, there are a lot of emissions coming from your vehicle. These are the outputs there. And this is a, yeah, which you have already seen. Now coming into the third phase, which is life cycle impact assessment. Um, Sorry, may I ask, are we already out of time, or how much time?
No,
Rajiv, are you
we
there?
have time, sir.
Okay. Is there Rajiv with us? I'm trying. Okay, then I will continue. Life cycle impact assessment phase. So this is the assessment phase. We have already defined the Golan scope, and also we have collected data in the life cycle inventory phase. Now we are going to assess the impacts, which is the most interesting phase for me actually. And this is also the phase which I am a leader for the European Commission for my project. And in this project, in this phase, we are going to convert all the inventory data to the environmental impact potential. So we have collected the data, right? We have collected all the input data, and also we have collected all the output data. Now we are going to convert all of this data to the environmental impact. And in this, maybe you are remembering the scope phase. We are defining which are the impact categories, which are the indicators, which are the life cycle impact assessment methods. We have already chosen in the scope phase. These are some of the mandatory steps that you have to define in the scope phase. And now we are going to group the data that we are collecting in the life cycle inventory phase based on the potential to cause certain environmental impacts. And this process is called classification. The data that are collected at the inventory phase, we are going to group it together based on certain environmental impacts. So this is classification. And after classification, we are going to do the characterization. And in the characterization, all the input and output quantities converted to potential impacts based on characterization factors. I will explain this with an example. So let's say, hope you can see my screen and you can see the classification characterization. And in the classification, in the life cycle inventory assessment, we have collected inputs and output data, right? And in the output data, we have got carbon dioxide emission, nitrate emission, SO2 emission, and all. Now we have to see which of these inputs and outputs are related to which environmental impact category. We have different environmental impact category like global warming potential, eutrophication, acidification, and so on. Carbon dioxide emission is directly related to global warming, right? And so that this carbon dioxide emission is classified towards the calculation of global warming. Now the nitrate emission is the major cause of the eutrophication. So that the nitration emission is classified for the eutrophication. And the SO2 emission is for acidification. Similarly, all the inputs and outputs are classified based on these environmental impacts. Is the classification clear for you? Why why it is classified and how it is classified? Is it clear for you?
Yes, sir.
Yes, sir.
Okay, thank you. Now we are going to characterize it. So each material flow is multiplied by a characterization factor which expresses its individual contribution to the environmental impact. Now you can see a table with first column 1 kilogram carbon dioxide and then a characterization factor, then a global warming potential. Would someone give me or explain what that table tells? If not, please feel free to tell no. You cannot understand. Please check. So the carbon dioxide has a characterization factor of 1. Methane CH4 has a characterization factor of 25. Nitrous oxide has a characterization factor of 310.
So it's basically the giving the values like equivalent values for other categories with respect to CO2, like giving it as one, how many times of it is the next or the third, and so on.
Exactly. Thank you, Pradiksha, again for answering. Yeah, as per IPCC, IPCC means International Panel of Climate Change. So they are the main organization who is reporting these climate change problems, and they are also giving the guidelines of how to calculate this global warming potential. So as per their guideline, this carbon dioxide is the main cause for the global warming potential, as you know. So we are connecting this global warming potential directly to carbon dioxide. So it has a value of 1. Now we have also the methane which is emitted to the atmosphere, which also causes the global warming potential. But comparing to the carbon dioxide, methane causes global warming potential 25 times to carbon dioxide. That is why we are giving a characterization factor of 25. Now we have also N2O also emitting to atmosphere, which also causes global warming potential, which is 310 times compared to carbon dioxide. That is how each output flows are characterized. Is it clear? You get the point?
Yes, sir.
Yes, sir.
Okay, thank you. So these are the major two steps in classification and characterization. One second, let me please switch on my light here. One second. Okay, thanks for waiting. And these are the two major mandatory steps that you have to do in the life cycle assessment as per the ISO standard. And some of the optional steps as per the here. So some of the impact categories here are resources, as Pratiksha told earlier: water, global warming, ozone depletion, acidification, eutrophication, smoke formation, human toxicity, ecotoxicity, waste, land use, noise, odor. All of these are impact category. And please remember the unit of the global warming potential, kilogram carbon dioxide equivalent. So this is how you measure the global warming potential. Kilogram carbon dioxide equivalent. Someone know why there is an equivalent? Why it is not only kilogram carbon dioxide and also there is an equivalent? I have already explained.
So, because it is compared with the CO2 concentration with the
Uh,
content.
yeah, some of there is some element in your answer, but mainly because you can see that it is not only kilogram carbon dioxide. We are also converting other outputs like methane, nitrous oxides, and also other outputs in terms of carbon dioxide. So we are converting everything in terms of carbon dioxide. That is why kilogram carbon dioxide equivalent. Is it clear, prediction?
Yes, sir.
Yeah. Okay, good. Now,
Sir, what about order?
please ask.
What about order? We can't do anything. Like, is there any, like, we don't have any measurement for that?
Measurement? Sorry, I don't understand your question.
For noise, land use, waste, for all this, we have some measurements like kg waste, equivalent hectares, like that. For order, we have nothing like that.
So if you want to assess it for a product, you have to do the life cycle assessment.
Yes.
So if you want to do the life cycle assessment, you have to collect all the inputs and outputs, and you have there are a lot of softwares available like LCA for experts, SimaPro, OpenLCA, Umberto, Brightway. There are many softwares like this. You can give these inputs and outputs to these softwares, and you can define the system boundary, functional unit, everything there. Then you can use certain life cycle impact assessment methods and can evaluate all this based on these indicators.
Okay, sir.
I think is that was did I answer your question? If not, please ask again. Sorry.
Uh, Sir, what my question is like for all this categories, we have indicator measurement, right?
Yes.
So for the last one, order.
Uh-huh.
So for this, we don't have anything. This is my question.
Okay, for order, there is not a defined indicator or a well accepted indicator for in terms of life cycle assessment. That is why it's not there. It's still under research.
Oh, okay.
Yeah, even for microplastics, even for microplastics, the research was going on for the last 3 years, and recently an indicator is figured out, but I don't remember which was the indicator. So there are a lot of research going on, which we are also doing in our institute.
In
Okay.
architecture and planning, like students use the smell mapping, noise mapping, such kind of things. All these people will map the noise and smell. For noise, we have measurements like in decibels, people will calculate it, and for smell, we can mark it, but we can't do anything. So
Mm-hmm.
how much is the intensity of this and how bad it is, we can't explain
Yeah.
in any unit. So in this condition, we are facing little hard to tell about it.
Oh, I don't know related to how far the research related to order
It's not
is going on.
particularly in planning. In architecture, also some people are doing while doing urban design projects.
Yeah. But remember that when you do this assessment, you are only considering the use stage. Sorry, use stage,
Oh,
right? It's not a life cycle perspective. You understand what I mean?
yeah, yeah, sir.
Yeah. Okay. So why actually we are doing this life cycle impact assessment? So just starting from emissions, for example, CFCs, halogens, there is a chemical reactions between chlorine and bromine, and then this destroys ozone, and midpoint measures ozone depletion potential. And in life cycle impact assessment, we differentiate the impacts between midpoint impact and endpoint impact. Midpoint impact, that is something like ozone depletion potential, and endpoint impact is what are the result of this ozone depletion potential. So this ozone depletion potential can result in skin cancer, crop damage, immune system suppression, marine life damages, damages to materials like plastics and cataracts, and many things like that. So you can divide the impacts into midpoint and endpoint, but in life cycle assessment mainly calculates the midpoint because the endpoint impact calculation is not yet well developed. Okay. And the final phase, we are coming into the final phase, which is interpretation. And here, now we have all the results of life cycle impact assessment. Now we are interpreting our results, which we have got after the impact assessment based on the goal and scope and also the life cycle inventory. And there are different approaches to do this interpretation. There is a significance analysis, sensitivity analysis, scenario analysis. These are the three main kind of analysis that you do the interpretations. In the significance analysis, you identify processes and materials that cause a strong impact. So after the life cycle assessment result, you are not only getting from the softwares, the mainly people do the life cycle impact assessment with the softwares because it's a very it's a Herculean task to do. Otherwise, to do it manually, you have 10,000 number of data, both input and output data, and it is very difficult to manually to classify them and to characterize each and every processes. It's a very long process, right? So most of the cases we depend on the softwares unless it's something new, very new. And also in the softwares, you can also see what are the impacts, environmental impacts related to a particular impact category based on different processes, based on different stages, raw material extraction. So how much impact do a product have from this particular raw material extraction stage? How much it has a percentage from production stage? How much it has from the use stage? And also different processes involved in the production, maybe drilling, milling. How much carbon dioxide emission is from the drilling? You can see every details from this all of the softwares, such that you can see the which has a strong impact, which processes or the which materials has a strong impact for a particular impact category. Then you can understand the significance of different processes and materials towards your final result. Also, you can do the sensitivity analysis. In sensitivity analysis, you do the effects of parameter fluctuations to the overall results. So a parameter, for example, let's say when you use transportation by truck, you use there are different kinds of trucks, right? With different tons usage, like 35 tons, 45 tons, and 55 tons. How the result changes when you use the trucks with different loading capacity, such that you can see what are the changes in your results. And also the scenario analysis. You can also compare different scenarios in interpretation. For example, if your brick manufacturing uses the electricity from coal, and also another one company manufactures bricks with the electricity from a renewable energy. So how this the result changes in these two scenarios? Or if you are transporting by one company is transporting by truck and another company is transporting by ship. So how these different scenarios, or how the result changes when you change some of the processes? That is scenario analysis, such that you can interpret your results with different scenarios, different sensitivity analysis. You can also identify the significance of different processes and materials in the interpretation. And even though life cycle assessment is a long process and it is as a ISO standard, it still has limitations, and we are working on it. It's not a complete assessment of all environmental issues because as the student name I just forgot, as Kirti already just asked the problem of noise or sorry odor. So its indicator is not yet developed. So it's not possible to measure odor as an environmental impact using the life cycle assessment. Not yet. This LCA can rarely, if ever, include every single process and capture every single input and output due to system boundaries, data caps, cutoff criteria, etc. If you have conducted some surveys or try to collect some data, you might have faced many difficulties when collecting data, right? So it's a almost every problem. It is almost there in every scenario is the problem of data requirement and uncertainty of this data, and also the characterization models. I have explained this. CH4 is 25 times of carbon dioxide effect for global warming potential. But even though IPCC says so, some other scientists say it is not right. It has different numbers. But we always depend on IPCC. So that the characterization models are not always perfect. Therefore, some flaws, it's not yet known what characterization factor need to be given. So it's under process. And also the sensitivity and uncertainty analysis are not fully developed. So these are some of the limitations of life cycle assessment. And after you did the life cycle assessment, it is necessary that you do the critical review if you want to disclose your study to the public. Critical review is a necessary component for comparative studies which you have to disclose to public. So this is something very important that you have to keep in mind. Okay, this can improve the credibility of your study. So the critical review process is also defined in the Golan scope, which is a mandatory thing if you are disclosing it to the public. It has to be external independent chairperson and at least two other members maybe if you want to do critical review. The summary features of an LC, I'm not going into detail here. Yeah, there are a lot of terms that you can see in the ISO 14040 and also 44 based on the life cycle assessment. We have no time to explain all. So let's see an example, a quick example of life cycle assessment. Which coffee is the greenest? I mean, the environmentally sustainable. Let's say we are going to compare the espresso, black coffee, white coffee, black instant coffee, white instant coffee. Let us see the result. So we have considered from raw material extraction till the end of life when we did this life cycle assessment. Let's see. So this is the results from life cycle impact assessment. So here we are seeing the kilogram carbon dioxide equivalent, which is the unit of global warming potential. Here you can see the different types of coffee in the x-axis, which is from espresso, black coffee, black instant coffee, and white instant coffee. And in the y-axis, you can see the value of kilogram carbon dioxide equivalent. So please can see that the most carbon dioxide or the most which is causing global warming potential is the white coffee, right? Why white coffee is has the highest carbon dioxide equivalent? Because it is using milk. And the second one is white instant coffee. This has a second potential. And even in white coffee, which is the largest contributor, it is milk, and the second contributor, I think, is the coffee production, and the third contributor is hot water brewing. And the other considered stages are transport and the retail packaging. So considering it as our system boundary and the main stages, so white coffee has the most uh, causes the most global warming potential. So with this, I would like to conclude my session. It's already 2 hours. So I would like to go to the questions. So I would like to have your questions answered now. So feel free to ask me questions from Golan. We have discussed. First of all, I have introduced what a WTH is. Then I have also introduced what HINAB is. Then I come into what sustainability assessment. Then I explain what is life cycle assessment. Then we see the four phases of life cycle assessment, Golan scope definition, inventory analysis, impact assessment, interpretation, and finally, I have also showed an example how to do it. So please feel free to raise your questions of any kind of any point that we have discussed today. I'm happy to answer.
Sir, thank you for your. We truly appreciate you sharing your knowledge and expertise with us today. So we can now have the
question and answer session. So, so I think Kirti has some questions to ask.
Yes, sir. My question is, can you please share any insights on emerging trends or developments in the field of life cycle assessment?
In the field of life cycle assessment, now the mainly trying to so mainly now the life cycle assessments are based on the retrospective based or already existing technologies. Now there are a lot of researchers going on how to do the life cycle assessment of future technologies, and also how to do this back casting from the future technologies to now, so that we can build the technologies based on our what results that we would like to see in 2050 or 2100, how we would like to see the world. So this is some one research that is going on, and every company would like to have a life cycle assessment person now, LCA expert now, because especially in Europe, because they are making it mandatory to have this LCA result for most of the products. So every company needs someone who is doing this LCA, and also a sustainability strategies. There are a lot of laws coming up every day, almost every day, related to sustainability in the European Commission. So we are trying to build our researches based on the requirement from policy level. So recently there is a sustainability finance came into mandatory, and last week Eco Design Directive have republished with mandating the eco design properties from coming years. Germany is also introducing the carbon tax from increasing the carbon tax from next year, like 45 euro, and all the companies greater than 250 employees need corporate social reporting for them. There are a lot of opportunities, and at the same time, research aspects are coming up based on the policy level most of the times. And at the research level, mainly I say prospective LCA, and I have also showed some of the limitations of LCA, like the development of the characterization models and solving the problem of life cycle inventory, collection of data, and solving the problems of connecting this life cycle inventory to life cycle impact assessment, solving the problem of weighting, solving the problem of normalization. So there are a lot of aspects going on in the research for related to life cycle assessment. And when you come to sustainability, among the three pillars, the latest one is social life cycle assessment, which I'm also mainly focusing now, because I think I am the only one who is working on social life cycle assessment related to automobile sector, because I don't know anyone else so far, especially in Europe. So most of my work is going on related to social life cycle assessment for automotive sector, and it is a very new field. So there are a lot of things to do there, and yeah, my main focus is also social life cycle assessment.
Yes, sir, I understood. And one more question. Sir, you have idea about this ecological footprint calculator and water footprint calculator in online?
Uh, no, I have not used them, because ecological footprint is different from life cycle assessment.
Basically, we have online calculators for this. Uh,
Okay.
we have to do it like using formulas and some other theories like that, but now we have online calculator. So now if we see this life cycle assessment, we can see this in a big scale and one many scale like that. And small scale, is there any possibility in future to calculate or to know how it will happen and all this in some online mode by individual?
So there are already a lot of tools. There are already a lot of tools to do this life cycle assessment online. There are already available. Was it your question? Hello, Kirti?
Okay, sir. Understood, sir. Got it.
Yeah.
Kirti, hello Davis, Rajiv here.
Hello, Rajiv.
Hello, Rajiv. Yes. So, Kirti, just to add on, we'll have one more session with Davis sir soon, very soon, on carbon footprint. Okay. So maybe to some extent on, although not fully ecological footprint, but on carbon footprint aspects, we'll have one more session very soon.
Okay.
Okay. Yeah.
In that
In
session,
that
maybe I will
session, maybe I
also
will also
try
yes, sir.
to
Try yes, to
show you
show you
a tool.
a tool. Yes, Davis. Yeah. So, any other questions, students? Please
Yes,
feel free to
Sir, I
discuss.
have.
Sir, I have.
Please go ahead.
Hello.
Yeah, Raghapriya.
Yes, sir. Sir, you were talking about the carbon tax being implemented in recent times for the life cycle assessment. So my doubt is like, how's the life cycle assessment contribute to the sustainable development goals, sir? Like,
Uh,
how can it be
so,
integrated with them?
so carbon tax is not directly related to life cycle assessment. Okay, life cycle
Okay.
assessment measures how much carbon, how much global warming potential is caused by the product. Life cycle assessment does not measure how much carbon dioxide is emitted. It's just the life cycle inventory. Okay,
Okay. Okay, sir.
and and, and life cycle, the relationship of life cycle assessment with the sustainable development goals. You can see that there are 17 sustainable development goals with a mixture of environmental, social, and economic aspects. And if you see, I think the SDG 13, which is the climate action, there are certain targets there and also the indicators there, which ask you to um, have certain climate carbon reduction target. So if you want to know the present amount of global warming potential of your product, you have to do the life cycle assessment. Based on that, you can implement certain strategies for your company or for your nation to reduce this amount of carbon dioxide or the emission of carbon dioxide from your nation until this year, such that you can develop a strategy plan for your country.
Okay. Okay, sir.
Any other questions? Anyone?
yes,
Pratiksha?
sir.
Yes,
Yes,
sir.
sir.
Pratiksha, go ahead.
Yes, sir. So my question was, you mentioned the terms midpoint impact and endpoint impact while explaining the phase three. So can you just elaborate those two, how to like segregate those two while performing the phase three?
Okay, when you do um, when you do the life cycle impact assessment, there are different life cycle impact assessment methods like CML, receive, use talks, and so on. In most of the and recently European Commission have come up with another one LCIA method called EF. So in this EF, so European Commission would like to use, everyone in Europe who is doing this life cycle assessment, they would like to use optional. It's not mandatory, but optional to use this EF impact assessment method. In the EF impact assessment method, when you do this, you will you can only measure midpoint impacts. You cannot measure endpoint impacts. But if you use some other environmental impact assessment methods like receive, you can also assess the endpoint impacts. These are separate. This is not same, and first you get the midpoint impacts, and from midpoint impacts you measure the endpoint impacts. And there are mainly three endpoint impacts. One is human health, another one is ecosystem damage to ecosystem, and another one is damage to resources. All the midpoint impacts that you are measuring are related to either one of these three. So this three is considered as the main effect. That's why we are doing life cycle assessment. That is why we are trying to protect the earth. Why we are very worrying about the climate change? Because of the human health, because of our existence. We are. It is not because we are caring about the environment. It is just because again our greed. That is, we are just trying to protect the environment. But many people don't know that we are trying to protect the environment because of our own existence. That is why people are just keep on exploiting the world. This is an endpoint impact. That is why we are trying to protect actually the climate and all.
Okay,
So,
sir.
Pradiksha, did I answer your question?
Yes, sir, but I just wanted to know how to categorize though, like differentiate both. Like, how will you define the midpoint impact and endpoint impact?
Uh, Midpoint impact is the state, and endpoint impact is the damage.
Okay, sir. Understood.
Yeah,
Thank you, sir.
you're welcome.
Any other questions, anyone? Anyone, any more questions? Okay. So if at all you still come across any question, don't worry. Keep that noted. We have one more session with Davis very soon. So probably during that session we can kind of get that clarified. Okay. Or else you can post it to me. I'll check with sir if at all you don't find time for that. But I think we can wrap it up for the day.
Thank you so
Students,
much,
shall we?
Rajiv.
Yes. Thank you, Davis. Thank you for joining us. Yes.
And I just want to talk a few words about Rajiv. And Rajiv is a great person. You know, he helped me a lot during my tough times. Maybe I will tell more detail about Rajiv in the next session.
Yes, yes, yes. So I'll take now there are some formal business Dave. So I think I'll get on to this. So we are because we are organizing this on behalf of on from SP Vijayawada side from the Department of Planning. So on behalf of the entire SPAV fraternity, I propose a vote of thanks. Would like to propose a vote of thanks to Davis Jose, our expert speaker for the day. Thank you very much for joining us. It I know that it was a late evening 5 to 7 session, so and we knew that you were tied up with a lot of family work, but we are very much thankful for you for making time for SP Vijayawada and coming to us and delivering this lecture online. So thank you very much, Davis. It means a lot to us. Thank you.
Thank you so much, Rajiv. And there are a lot of wonderful students who were really interested and asked questions and interacting with me. I'm so happy to talk about life cycle assessment and sustainability with you. Thank you for your invitation.
Thank you, thank you. So this time I couldn't introduce my students to you. So probably next session, if when I'm a bit more free, I can because today I was a
Yeah.
bit tied up with a thesis review also. So, but we
And
generally have that session where the students also kind of introduce themselves to the speaker to make it more the speaker knows who is his audience also whom he's addressing.
yeah,
So
no
thank you,
worries,
Davis.
Rajiv.
Thank you very much. Have a pleasant evening. Thank you.
Thank you. Thank you. See you all.
Thank you. Thank you.
Bye
Thank you,
bye.
guys. Thank you, students. Thank you. So, Sanskriti, you can close the chat.
Yes, sir. Okay.
Yeah, I hope the rest of them were also there and all were listening. Okay.
Yes, sir.
Yes, yes,
Yes,
good.
sir.
So, tomorrow we'll meet in class. Okay, guys? Maybe late in the evening because from morning till evening I'll be there in MERP thesis review again. Okay. So, late evening we'll have a discussion.
Okay, sir.
Yeah.
Okay, sir.
And is sir there on the chat or sir is not there?
Ma'am, sorry, sir. Sir left.
Sir has left. Okay. So you can close this chat, Sanskriti.
Yes, sir.
Yeah. Thank you very much.